adjusting to the sun so that it's not using as much energy in the room is why they do that.
Yeah. I would buy that on a day like today when it's beautifully sunny out. They were doing it last week when it's cloudy out too.
Well, but it was changing.
Last week it wasn't. Last week it was consistently over. In my classes
Really?
anyway.
Okay.
Yeah, and the motion detector thing I don't buy as much in class because I'm constantly running around back and forth. So, yeah, it's cool. We'll just keep slow play. That's a cool phrase. I've never heard that before.
You haven't got slow play? Or
No.
slow played you?
I guess I have been. I realized.
I just did.
I just did. Some sucker. well done, Crystal. Well done. Anything else in here give you guys grief? Please, take a look. Please,
I
Beth.
just have a question. When we were doing the ones where we go in and we play with the up and down, the spreadsheet you gave us,
Oh, gotcha.
I realized that you do half of them all the way up and half all the way down, but why do we do that?
That's a great question. Thank you. So Beth's referring to this one down here. It's I'm randomly sampling 10 consumers from a mall, and we're trying to see what their average age is, and also the plus or minus around their age, the standard deviation of their ages. So I gave you a little two questions. First, suppose you grab 10 people, and they're all exactly the same age rather than the nearest year. So they're all 23 years old. And the question is, if they're all 23 years of age, that means their average age is 23 years. Yeah. What's the standard deviation of their ages? It's got to be 0 because they're all the same age. What is the definition of standard deviation, friends?
How much deviates from the average?
Average from
Good. That's empirically, or not empirically, in spirit what it is. But mathematically, more mathematically, it's
the average data.
exactly. Shelby knows you have to use the word average twice. It's the average
Data from
deviation or distance of the data from. Perfect. So basically what you have to do is you have to, if you want to get any kind of mathematical quantification for a standard deviation, you have to figure out those distances. And that's what I did with the spreadsheet down here. In E7 it says, okay, that's the smallest possible standard deviation. And if they were all the same ages, it would always be 0. If they were all 17 or all 18 or all 19, awesome. Here, this is just a little spreadsheet that lets you play with figuring out what the maximum standard deviation would be. Let's make this so we can see this.
Depends on the average.
Say again?
It would depend on the average. Because you can't be below 0.
I'm sorry, say that one more time, Tabitha. Was that you?
Yeah.
Go ahead. I just couldn't hear you.
I was just thinking it would depend on the average.
Oh, it totally does. And that's why I set the sheet up to do the average for you. So basically, what you're looking at right here, in case you didn't get a chance to look at this yet, you've got 10 little dots up here. Each one of those dots, it corresponds to one of the ages down here. So for example, this guy right here appears to be about 20, which one is it? It's probably the smallest one, 26 or 25. That's 25, that's 26. That looks like a 32, I'm guessing that's that one right there. This red box right here, there's your average. So that's the balance point. If you had to put a fulcrum to balance those 10 points, that red point is where your finger has to be to balance it. So what you needed to do with this one was to mess around, no, actually, one of the planes off for this part. I wanted you to kind of mess around with the ages to figure out how big the standard deviation you get. Right now it's at 18.2. So our Shelby's average distance from average is about 18.2 years. Can we make it bigger? Can we make that larger? Kelsey says, yes, we sure can. So let's just grab one. Kelsey, give me an idea.
Put a couple of them all the way, the oldest and a couple
All right.
of them the youngest.
Okay, and this is the one thing I couldn't figure out with Excel. I put these sliders in here, but when you go up, it seems like that should get bigger, but they actually get smaller, and I couldn't get them rotated around, so hopefully you can forgive me for that one. So make a couple at the oldest, a couple at the youngest. So I go, let's go oldest, youngest. Are we having the desired effect, friends, on the standard deviation? It's definitely, look at it down there. Here it is right here. It's definitely getting larger as I make these things more extreme. Are you seeing how the average is changing as I'm dragging these ages around? Look what the average is doing. It's chasing the extremes. It's chasing, that's exactly what it's supposed to do. It moves as 9 data points, keep it G-rated in here. As 9, I see you, everybody. It's for posterity, you know. As 9 data points stay fixed, the average is going to follow that one. And the more extreme it gets, the faster it's going to move. So, we're at 24.4. Beth, you had a theory back there. What was your theory?
I just put all up to the left of the middle
So we go top. So these are making, all these are now 17. So those,
Yeah, and then all the rest down.
and pull these all down to here.
Right.
Okay, beautiful. So you're saying 33.7 is the largest you can get. You are correct. Now, the best question that Beth asked is not what is the largest standard deviation, but rather, why is it? Why does that result in the largest possible standard deviation? So for example, let me go half with Beth's solution and partially with Kelsey's. I want to take, you did half and half, right, Beth?
Yeah.
I'm going to take this H5 right here, and I'm going to move it to the other side. So essentially, if you think about it, I have the same setup. I've got all the extremes, but I've got 6 at this extreme and 4 at that extreme. And what happened to the standard deviation? It went down a little bit. It went down a little bit. Why? Think back to Shelby's definition of what the standard deviation is. Say that again, a little bit louder. I'm an old man, my hearing's going.
The average of the average.
It's the average distance from average, right? So when we were split evenly, this is beautiful. When we were split evenly, where was the average, friends? Directly in the middle, isn't it? It's directly in the middle, halfway between, because you got half and half. This is, just FYI, this is a place where you wouldn't use the average, right? This is a data set where you go, oh yeah, the average age is 49 years. No, half of them are 17, half are 81. That's head in the oven, feet in the fridge, right? This is, I'm not saying you would use the average here, I'm just saying that's what it is. What happens when we grab that age 5 and send it to the other side? What happens, friends? The average got skewed and it moved towards that one that moved to the other side. So now what you have is you have 4 distances to these 4 data points that are now each larger than they were originally. But the one that was over there is now on this side, and that distance is shorter than it was originally. You see what I'm saying? And the more we move over, the more exaggerated it becomes. So if I grab age 3 and bring him over, goes down again, goes down again, goes down again. And you see what happens. Now you have the exact same, it's still extremes. It's still extremes. But you have 1 large distance and 9 little distances that average out to not such an extreme number. Is that ish? I would never ask you to mathematically prove this either on an in-class exam or on an out-of-class exam, because the mathematical proof for this is far too tricky. I wanted to do exactly what you did, Beth, which was mess around with it and come up with the solution. And then hopefully spur a discussion in class where we go, oh, that's why. That's why. That makes sense now. Fair?
Fair.
Fantastic question. Fantastic question. Francesca, go.
Just a real quick.
Go ahead.
Whenever it says between the numbers, it actually means including.
I put the word inclusive in there to prevent any doubt. Yeah, that's an English question that I can't answer. Francesca's got a great one. She said, when it says between 17 and 81, what between do you mean? Do you mean brackets or parentheses? And I always like to use the word inclusive to include them and not the word, yeah, I'll make it clear. Because English does get in the way of our discussions in here sometimes, as you've noticed. I barely speak English, I speak Delaware, which is slightly related. Cool? Let's take 5. You're getting that glazed look. Yeah.